Hello guys, so today's question is open the lock. So let's just quickly go to the question. So we have a lock in front of us with 4 circular wheels and each wheel has 10 slots, and these slots are numbered from 0 to 9, right? And the wheels can rotate freely and wrap around, but we can rotate it in clockwise or anti-clockwise, right? The lock starts initially at 0, a string representing state of 4 wheels, and we are given list of dead ends, so such that while rotating the lock you will form numbers, right? And if these numbers are any number which is in the dead end array, then you will return from that particular instance and you will not be able to reach your target, right? So given the target representing the value of the wheels that will unlock the lock, return the minimum number of turns required to open the lock, or -1 if it is impossible. Okay, so I guess most of you are kindly worried about this particular question because it doesn't seem to give any hints, and with the last hint we could tell that this might be solved using your dynamic programming, or your backtracking or recursion, right? Yeah, so what if I tell you this question is a graph question? Feels surprising, right? Even I was perplexed when I first started solving this question, but yeah. So we have multiple examples going on here, but I've given you a gist of idea like how these things will go on. I know this thing doesn't make any sense if you read it like this, so I'll explain it to you. Let's just quickly walk through the constraints. So here the dead ends length is 500 and the dead ends of I length is strictly equal to 4. Similarly the target, right? So there are no 5 or 3 length strings. The target will not be in dead ends list. If it is dead end list, it is not meaningful to search, right? Similarly, targets and dead ends of I consists of digit only. There are no letters or any other special characters in that. Okay, so let's quickly hop on to the intuition and let's just solve this particular question. Yeah, so before diving into the actual question, let's just understand that how this particular lock is being worked, right? So given the size of the string is 4, means we have a 4 numbered lock which is the input string 000. Assume that you have a 4 slots, right? So these slots has numbers from 0 to 9, and now these 0 to 9s can be inputted into these particular field by rotating that particular lock, right? So you might rotate only one slot. The constraint is rotate a single slot at each step, right? So you are not allowed to rotate simultaneously 2 or 3 slots to get your particular target, right? That is not efficient. So you might choose any number from 0 to 9 and you will turn to that particular number in this particular slot. Assume that I am turning at this particular slot, so you'll turn and you'll make that number 9. So if you are having your number 0008 in your dead line or dead ends list, right? So 0008 will be encountered when you turn 0009. So hence you cannot reach 0009 because 0008 is already there in your dead ends. So this is one of the main criteria for this particular question, which is very vague, which is not discussed in the question explanation itself. So I'm telling you because of the test case that is being involved in this question, which we'll see in the next step, right? So this is the intuition or approach to solve this question. And now you need to get to your target by comparing the deadline and your particular number from 0000 is equal or not. If it is equal, you will stop, you will return -1. If it is not, you need to go again and again by incrementing your chances, right? Okay, so let's quickly move on to the test cases, right? So here we are given the dead ends array, and we have the dead ends here, right, which is a string based array, and our target is to reach 0 to 0 2 from 0 0 0 0, right? So how can I do that? So you choose any position, right, not in this particular order, but I'm explaining this particular order because it's given in the example test cases, right? So the initial string is 0 0 0 0, and next I've chosen this particular position, the leftmost position, right, the most significant bit position if I'm talking in terms of bits. So this position is chosen and it is turned to 1. Okay, so check if this newly arrived number is present in this list or not. It's not present, hence continue, increment your count, now +1. So move on, I'm checking with the second position and I turned it to 1. So 1100 is my string. Is it present in the dead ends list? No. Move on, +1, +1, right? Now this 1100 position, the end position of 1100 is chosen, right, because we are going to make 0 to 0, right, obvious case. So this 1101 is present in dead ends? No, right? So you increment your count, and this 1101's this position, right? So the third position from the left, or from the right towards the left, is chosen and it is made to 2. I've turned it to 2, right? Now check if 1201 is present in this particular dead ends list or not. It's not present. Now you can increment. Now your 1202. So how did I arrive at 1202? I chose this last bit and I've incremented it to 1. I've turned it to from 1 to 2. So 1202 is present in this list? No, right? Why I have not chosen this particular index? Because if I turn it to 1, the 12 will interfere and it will return -1. So I do not want that, right? So next thing is, what I've done is, this last index where 1 is present, I've turned it back to 0, right? So 0 to 0 2. So how many steps did we arrive at this solution? 1, 2, 3, 4, 5 and 6. So your answers is 6 steps. So this is the minimum number of steps to do, right? Similarly, your dead ends is this, a single array, and you have 0 0 0 9. So what I can simply do, I'll just choose the last index and I'll move to 9, right? I turned it backwards, because if I turn it from front, I have 0 1 2 3 4 5 6 7 8. So these numbers are there to reach 9. But if I turn it backwards, because it's a circle of cylindrical circle to turn, if you have observed the cylindrical locks with numerical pattern, it has a cylinder, right? So I've turned it backwards, right? So it is now 0 1 2 3 4 5 6 7 8 9 and 0 1 2 3. So this pattern continues. So 0's previous thing is 9, right? So I've turned it to previous and the chance is 1. So answers for this particular question is 1, right? So similarly, we have a lot of dead ends here, and our target is to reach 888, right? So let's try to reach 888. So 0 0 0 0. Okay, I've chosen the first position, I've turned it to 8, similar to the first test case, right? Similarly, I've chosen the second position where I've turned it to 8. These two are not present in this particular dead ends list. Next, I've checked the third position and turned it to 8. 880 is also not present in this dead ends list, right? So next, I've moved to 88888. Now you might tell me that, okay, we've reached our target, right? But the answer is -1. Why? Because when you are turning to 8 from 0, right? If you turn it anti-clockwise, you might get 9, right? So 8889 is also present, right? And if you turn it clockwise from 0 1 2 3 4 5 6 7 8, if you go here, the 7 will encounter and you eventually form 8887, which is also there in your dead ends list, right? So you cannot reach 888 without encountering these both in either ways, right? In clockwise or in anti-clockwise positions, right? So you cannot reach target triplet, hence your answers is -1, right? So I guess now you have a clear-cut understanding of the test cases, right? So this understanding makes the approach of BFS or the graph traversal algorithm, you might also implement it using DFS, makes it very much easier. So I wanted to highlight this triplet point in this previous intuition because this is not mentioned in the question, right? So yeah, so why is a graph question, right? You might think, okay, this is not a graph question, so why it is a graph question, right? So I've already discussed about the rotation of the elements in clockwise and anti-clockwise, right? So assume that your cylinder, your particular LOX cylinder at each and every position is like this, right? You have similar kind of cylinders like the other three in a similar fashion. I'm weaving it from side, right? So these are connected in this manner, right? So assume that I have a center to rotate, and this is the first number appearing from your eye, right? So this is your eye, this is the first number appearing there. Okay, cool. Now see that I've represented it in a unidirectional graph, right? So this is a variation of a bidirectional graph also. Why? Because I can move from 0 to 1 or 1 to 0, which makes it moving forward or moving backward, right? Similarly, I can also move to 9 and I can also move to 0, right? So this works for everything, and this particular implementation is a graph implementation, and this brings us to use the graph traversal algorithm to solve this particular problem, right? So to make a more emphasis upon this, instead of making a adjacency list or adjacency matrix that we discussed in the yesterday's question, I'll use a map, right? So map makes easier. I know that if you are a Java user, there is a particular term called hash map, which I prefer to avoid because hash map introduces a log n extra time complexity in insertion or deletion, right? So simply use a map data structure. So similarly, I've mapped it in a previous map. Previous map is like going in a anti-clockwise sense, right? So 0 is mapped to 9, 9 is mapped to 8, 8 is mapped to 7, 7 is mapped to 6, 6 is mapped to 5, 5, 4, 3, 2, 1, and so on. So which I've written in the order, right? And now next map is like 0 is mapped to 1, 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 4, 4 is mapped to 5, and so on, right? So these map structures makes us efficiently use the on-time retrieval in a big of one time complexity. Okay, so let's just discuss about the coding approach with this test case 3, right? So as I've already mentioned that we'll turn this particular test case clockwise or anti-clockwise, right? So what can I do? What can I do if there is a particular string that's been given to me, which is 000? So in a traditional BFS question, we'll take a queue. So what I'll do is I'll maintain two different sets to maintain the track of the numbers that are arriving, right? With the different combination of numbers from 000. So I'll add 000. So I'll maintain two sets. So one is visited and one is obviously the deadlines. Okay. So deadlines, we'll convert these deadlines array or list into set, right? Make sure you convert your deadline, right? So I'll quickly note down the deadlines and let's just solve this question using this BFS approach. Okay. So these are the deadlines that we have, and we have visited nothing, right? Okay. So what will I do? What will I do? So basically you will pop something from queue in a traditional BFS, right? So before popping this, what is the size of the queue? 1, right? The size of the queue is 1. So the size of queue is 1, and now I'm popping the particular string or the input string that is present in the queue. The target is reaching 888. Okay. So the popped string or the removed string from the queue, I'll check with the target. I'll compare this popped string with the target. Is it equal? No. Now what I'll do? I'll take this particular combination. With the length of 4, I need to choose one particular digit, right? So for I plus plus, what I'll do? I'll just check a particular instance, right? So out of this all, I'll choose the first index. I want to move from right to left in a serial order. Okay. So what I'll do is I'll convert this particular string to a character array. You can do in your language of choice, right? Character digits is character array of your current string, which is 0000. The current string is q dot poll or q dot remove or q dot tq, right? Okay, so I've taken this digits array and I'll store the original digit, right? Mind you, this original digit uh, should be replaced when you make changes, because this particular digit is already been visited, right? So now what I'll do is I'll store this character original, which is digits of I. Now I'll perform operations. So as we earlier discussed, we can turn it clockwise or anti-clockwise, right? So let's turn it clockwise. So to turn it clockwise, we need to get the next digit, right? So I want to change the digit. So to get the next digit, character next digit, we will use the next map, right? So next dot get of this particular digits of I, right? So you got your next digit. So what you'll do is digits of I is equals to next digit. Okay. So now our string is 0001 because zeros next is 1. So 0001. Now what we'll do is we'll convert this particular character digits array to a string. So string next combination is equals to string of digits, right? Okay. And after this the checking condition, I'll quickly erase this off and we'll just go through. Okay. Now the checking condition would be your particular newly formed digit, which is next combination, is not present in your deadlines set and your visited set, right? If your visited set not contains your next combination and your deadline set also not contains your next combination, what you will do? You will simply add it to the queue, and then you will also add it to your visited, right? Because we already visited it, right? Your next combination, right? So now the 00 is gone and now our next combination is 0001, and the previous combination for this would be what? So the only change that we need to do is the logic remains same. Only change we need to do is instead of getting the previous digit, instead of getting the next digit, we'll get the previous digit, right? So previous digit is equals to previous map dot get of digits of I, and you'll form the same string again, and now you'll push 0009, right? And after all these things you will do, we stored our original digit, right, from this digits array. So now at end you will make digits of I is equals to your original digit, right? And after this for loop you will increase your chances plus plus, right? At the end you will return minus 1, right? Simply you will remove this, you go on doing this until you reach your target. If something is encountered, something will be encountered in this, you will return minus 1, right? That condition will be after the queue is empty, right? That will do in the traditional BFS. What if your input string is also present in your deadlines array or your deadlines set? So you need to define a base condition. If your input string is present in deadlines, then you will return minus 1. Okay, so this is the intuition. So let's quickly walk through the code that I've written in Java, right? So we have a deadline set, as I've already told you. This deadline set is used to convert the deadlines array or the deadends array to a particular set data structure. And similarly the visitor, the queue, and we have two maps, next and previous. So we'll offer the particular input which is 0 0. Similarly we'll also add it to the set. We'll initialize the chances to 0. Now the queue will be empty. The queue will be empty initially, but you pushed your 0 0 0, so queue is not empty now. So until your queue is empty you will do this particular operation. Now you have your size, you will get the size of the queue, and until your size of the queue, right, until your size of the queue, you will get the current string, right? If you have 0 0 0 you will get the current string and you will remove it from the queue, right? Now you will check your current string is target, you will return chances, right? Else you will do the operations that we have discussed, right? The operations are like this. So you'll convert your input string, your current input string, this which is current, to a character array, and then you will make a character original digit which is the actual digit, right? Then you will get your next digit from the next map. Now you will define your next combo, right? And you will define your basic BFS approach where you will check your dead end set and visit set, right? If it is not there you will push it onto the queue, you will add it to your visitor. Similarly we'll do it for anti-clockwise. Here instead of getting from the next, we'll get it from previous and we'll add it. And after this all operations are done, you will change your digits to the temporary original digit which we stored previously, right? Now you will increase your chances after two for loops outside, right? Why after two for loops outside? Because we are doing it till size, right? If your size is 1, you will only do it one time, but you have your 0 0 0 1 0 0 0 9 in your third test case. So you will should pop both and you should add all the possibilities to that particular queue in the next iteration, right? So this is a particular code and I'll be giving you the Java and the C++ code side by side in the next upcoming slides, and you can get a quick glance through them, and also you could just get a glance of how to define the maps for the next and the previous also. So thanks for watching this video, and please stay tuned for the next daily LeetCode questions, and also do not forget to subscribe the channel.